sorry. Actually, we have to be relaxed. Okay. But the problem will always coming. So loud.
Check. Good morning, everybody. Yang kami hormati Bapak Direktur Polytechnic Ahli Usaha Perikanan, yang kami hormati Bapak Dr. Maman Hermawan sebagai moderator pada kuliah. Dan yang kami hormati Bapak Ibu dosen yang berkenan hadir pada kuliah umum pada siang hari ini, serta adik-adik taruna sekalian yang kami cintai. First of all, we would like to say welcome to our guest, Dr. Nakamura. Thank you very much for your time to attend our general lecture. For today, we will start the general lecture, but in the beginning, we would like to invite our director, Bapak Dr. Heri, for welcome speech to this agenda. Kepada yang terhormat, Bapak Direktur, disilahkan.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. His Excellencies Mr. Dr. Shinsaku Nakamura, Ph.D. as the Senior Researchers and International Cooperation Department, Space Industry Division, Japan Space System. Excellency Mr. Dr. Maman Hermawan, Master of Science, Associate Professor at the AUP Polytechnic. Excellencies, the Vice Director, lecturers, staff, student AUP Polytechnic, as well as valuable participants. First of all, I would like to welcome Mr. Shinsaku Nakamura to Jakarta AUP Polytechnic under the Ministry of Marine Affairs and Fisheries. For information, Jakarta AUP Polytechnic used to be Jakarta Fisheries University in 2022 until 2024. And the AUP Polytechnic focused in the strengthening the transformation of the one single institute in the Ocean Institute of Indonesia. They produce superior human resource in the relation to the blue economy. Mr. Shinsaku Nakamura and all the participants producing superior human resource, the AUP Polytechnic is supported by 6 applied bachelor study and 1 applied master study program at the active specialization, with the vision of becoming a center of excellence of merit and fisheries vocational higher education toward the world-class Ocean Institute. The combination of educational patterns that focus on mastering technical competence, teaching factory and developing an entrepreneurship spirit in the fisheries sector, as well as building a strong character, is the main provision in building marine and fisheries human resource. We have to carrying the motto, care for quality, continue to work and innovate. with the slogan Jalan Rita Sarva Jibitan, which means the seas in the source of life. Also, again, welcome to our institution. I wish you pleasures and thank you for giving a general lecture today in AUP Polytechnic. Thank you very much. Good morning. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Bapak Direktur. The next agenda, this general lecture will be led by our senior lecturer, Bapak Dr. Maman Hermawan. Please.
Pak Ketut, waktunya kira-kira? Oke, alright. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning. The Honorable Director of AUP Polytechnic, Jakarta, well known as Jakarta Technical University of Fisheries, Bapak Dr. Muhammad Heri Riyadi Alauddin, SPI MSc, the Honorable Dr. Shinsaku Nakamura, the Senior Researcher, International Cooperation Department, Space Industry Division. Dear all lecturer, and all of my beloved student, para taruna-taruni sekalian, tepuk tangan dulu. First of all, let us thanks to the Almighty Allah Subhanahu wa Ta'ala because of His blessing. We are able to come here to join in this general lecture with the topics brief introduction to satellite data analysis for marine affairs. Before starting this lecture or our agenda today, I would like to express my most sincere gratitude and deep appreciation, especially to Dr. Shinsaku Nakamura for his invaluable lecture today, we hope. I also would like to extend my gratitude and deep appreciation to the all lecturer, especially Pak Dir, sudah datang di sini Pak, terima kasih telah menginisiasi acara ini. Saya kira ini adalah terobosan penting bagi kampus ketika kita kampus menjadi lebih besar ke depan. Tepuk tangan dulu. Karena waktu yang sudah sangat mendesak dari hari Jumat, so ladies and gentlemen, the presentation today, as I mentioned before, is about brief introduction to satellite data analysis for marine affairs and fisheries, we hope. Yeah, not only of marine affairs and fisheries, right? Okay, let me introduce for more detail our guest lecturer, maybe minta maaf ya, ini biasa banyak perintahnya. Nanti Pak Nakamura akan menyampaikan juga memperkenalkan dirinya nanti dalam paparannya. So karena waktu, so now I will deliver our agenda of general lecture today in detail. That are the first session is presentation time from Dr. Shinsaku Nakamura. And the second session is opinion. So please, if you have an opinion or question, yeah, and then Dr. Nakamura will respond to our question. And the third session is closing of general lecturer. Ya, Pak Dir, demikian. So, well, ladies and gentlemen, for the next agenda is presentation session. Please welcome Dr. Shinsaku Nakamura.
Thank you very much. Okay. Selamat pagi. Nama saya Shinsaku dari Japan. Today, I'd like to introduce about remote sensing GIS data analysis for marine affairs, especially for fisheries, perhaps. Would you mind to show up my slides, please? Okay, thank you very much. So the title is Brief Introduction to Satellite Data Analysis for Marine Affairs. And please, next. And this is my simple introduction. So I graduate the engineering school at Hokkaido University. Then my background is about mining environment, not for the marine, I'm sorry, but I study about remote sensing GIS data analysis and also data management. So I can say I'm a data analysis, and I'm very interested about the Indonesian areas, especially for marines, because now for 5 or 6 years ago, I met Pa Nyoman, your director of the agency, and we had a very good discussion about how we can collaborate, Indonesian government and Japanese government, how we can collaborate together for developing satellite systems and for marine affairs. Now we cooperate together, and now we establish one project named the Enhancement of Ability of Satellite Data Utilization for Monitoring AUP fishing activities in Indonesia. So this time I also came here that project, and now I'm going to develop with KKP staff for data applications and also data platform. Next, please. And before we get started about the satellite, I'd like to introduce our organization, Japan Space Systems. Japan Space Systems is not a company, it's a non-profit organization supervised by Ministry of Economy of Japan, and also Cabinet Office of Japan. So we contribute to develop space industry. How we can improve the space industries, how we can apply science technology to industries like fisheries, not only heavy industries, but also fisheries, agriculture, mineral exploration everywhere to the world, and for Japanese economy too. So we have investigation and consultation. We have research and innovation, and also we operate satellite and rocket launch system, and also we analyze satellite data, and we have a good, this is my sections, international cooperation. And also we have GNSS, that's the positioning system, like GPS, Galileo, Michibiki, or something like that. Next, please. And we believe that satellite data and GIS data are very useful, very powerful tool for various activities on the earth, human activities, like not only fisheries, but also agriculture, forestry, mining, environment assessment, etc. Of course, enhancing the science technology too. Next, please. And this is today's my content. So I'm going to introduce about what remote sensing is. And also we have two types of remote sensing. One is optical sensor. The other is radar sensor. And we would like to compare the difference between optical sensor and radar sensor data. And also I'm going to introduce our technical cooperation project with KKP, Ministry of Fishery, and also last time I have a sync observations with Kakape staff, and I'm going to introduce about the results of satellite data analysis. Next, please. Next, please. So this is what the remote sensing is. Remote sensing is a technique to obtain information about the phenomenon of objects without direct contact. So not only satellite, but also I think you're familiar with X-ray, even digital camera, also the remote sensing, they can capture the information with the distance. Of course, echo, maybe some of you guys to use echo system for detecting fishing ground or bathymetries or something like that too, I think. The next, please. So those are remote sensing. Next, please. Okay. Now, the remote sensing, we are using sensors, not on human eyes. So we're going to detect electromagnetic radiation. It's like a very tiny or very wide wavelength. For human eyes, we can recognize this electromagnetic radiation between 400 nanometers to 750 nanometers only. But in the world, we have a various wavelength, and every materials can reflect those electromagnetic radiations. So remote sensing technique, we're going to receive those signals from the satellite, and we can analyze what's up on the earth or what's up on the ground. Next, please. So this is the types of remote sensing. Now we are focused on spaceborne, but also we have airborne materials. Maybe some nowadays we have a drone to detect the location, detect the areas and phenomena on the ground or sea surface area too. Next, please. And for the spaceborne remote sensing, we have 3 types of data sets. One is optical sensor. The other is radar sensor. And the last one is digital elevations. Digital elevation is not the actual remote sensing data, but we analyze optical sensor data and radar sensor data to provide digital elevation model. Next, please. And those are difference between among those 3 sensors. So optical sensors, we are using sunlight to detect the light reflection from the ground or sea surface. And also those sensors can detect thermal radiation from the ground without the sunlight. And microwave radar sensors, the sensor can shoot the radar to the ground or sea surface, and this sensor can capture of the radar of backscatter radar power. So if we would like to use radar sensor, microwave radar sensors on the sea ground, sea surface, the microwave can reflect to the other way because the sea surface is very flat. But if we have ships or some buildings on the sea ground, sea areas, the object can reflect the radar data to the satellite, and we can identify what's up, what on the sea surface. This technology are very useful for for fisheries or marine affairs. And that time, after this, later of my presentations, I'd like to introduce about the technology for illegal fishing boats detection. Next slide, please. And next. Okay. Now, this is the optical Now, I'd like to explain about the optical sensors. Every materials, every phenomena on the Earth, they reflect sunlight, sun power, or they have thermal energies, and they comes up the near infrared thermal powers, and every materials have unique unique spectral curves. So each point, the sensors can capture the reflectance power, and they can we can analyze the species of the trees or the materials on the ground. Next, please. And there are some of, how to say, famous satellite sensors. Now we are operating, not only us, but also people around the world operate sensors. Now, Hisui is our optical sensors, which we launched in 2019 before COVID-19 pandemic. And this is the world leading technology for satellite observations. Every satellite has multispectral sensors, so which means that each sensors can detect the point of wavelength, which, for instance, wavelength, but Hisui can capture from the human eyes from 4,000 nanometer to, I forget, 2.5, 2,500 nanometers wavelength continuously. So which means that we can analyze those satellite data and we can detect exactly what's up on the Earth. So next, please. So this is the specification of our satellite sensor named Hisui. So we have 185 bands of satellite sensors, and we can capture every phenomena directly and continuously. Next, please. So now, can I have raise a pointer or something? Or if you don't have it, it's okay. Thank you very much. Okay. Okay, okay. Where's the point? Okay. Oh, I see. I see. Now, let's talk about the optical sensors features of especially for Hisui. But 難しいな。こういうわけで。Well, it's a bit difficult to explain without the pointers, so I'm going to skip that slide. But if we can use history data sets for data analysis, we can detect every species in the forest or every materials on the ground, something like this. So now you can see the left top of the forest image. Even human eyes, we cannot identify which species in the forest, but once we are using history hyperspectral sensor from this sky, from the space, we can analyze which species of trees in the forest. Every single trees we can identify. So that's a very powerful tool nowadays. And this is about Uganda. That's the African countries. And Uganda has a huge lake named Lake Victoria. And it's, how to say, its coastline are now decreasing. We can compare with the satellite observation time with the time series and how much amount of forestry, how much about uh, so vegetation on the sea surface, not sea, lake surface area decreased by some human activities, something like fertilization of the waters or mm, I'm not sure this time. Well, yeah, fertilization or the falling the balance of human activities and also maintaining of the environment. And this is Indonesian coastal lines. It's just 30 kilometers away from Jakarta, and there was a mangrove forest in 2000. Wait, eh, to, 1976. There was a mangrove forest in the coastal area, but for the for aquaculture of I think shrimp pond they developed, but mangrove protect from the coastal area from the waves or tsunami or coastal erosion, but they cut down the mangrove and try to make a shrimp pond. Of course, economic are very important, but because of they cut down the mangroves, the coastal erosion happened. So we can compare with satellite image and how much damage they had for the shrimp pond and also tsunami or coastal erosion by cutting the mangrove trees forest. And this is the magnified image at the locations. And at that time, it was, I think it was 2018. My boss and I was there to monitor and compare the satellite image. And it was a very serious problems happened. It's supposed to be the land, but the waters come out and nobody can live anymore. So it's a very, very sad situations we faced. Now, let's move on to SIR sensor. It's a microwave. So microwave, this sensor is a very bit different from the optical sensors. Optical sensor can capture the sunlight reflection from the surface of the earth, but microwave sensors, the sensor can shoot the microwave to the ground and they receive the power from the surface, backscatter power from the surface. And this is a very unique thing that the microwave can penetrate, through the crowd and also even L-band, like the wavelength like 18 centimeters wavelength can also penetrate the trees and we can detect the ground exactly. And we can detect the phenomena on the earth, on the sea surface directly. So as you can see that the red image about the optical sensors data set, and we can see the blue area is like illegal mining areas in Peru. I was also there to compare with the satellite image, and also we have my boss and I have some lecture to the park rangers to detect and which area they have to protect for the next. On the right image, it's optical sensors, and we cannot say that which area, which rivers or where is the next target area for illegal mining, but use the radar sensor. You see the yellow circle, there's the rivers. Radar can penetrate the trees and they can detect the feature of the ground and we can find out the potential rivers for mining. So we can suggest to the park rangers which rivers will be the potential area for the illegal mining for next. So we can suggest them to have a patrol more around these rivers with satellite image. So this is a very important technologies for monitoring or environmental assessment. Technical cooperation. Okay. Now, let's move on to the technical cooperation, which now our team and also KKP team collaborate together. So this is the overall goal. So efficient and sustainable surveillance on IU fishing vessels is operating based on open platform. And also the project goal, we enhance the capacity of KKP staff to utilize multi-source satellite data for monitoring IU fishing vessels in Indonesian Ocean. And we have two outputs. One is satellite data applications. We are now using ALOS-2, that's a Japanese microwave spaceborne sensors, and we're going to use those data sets to detect bad guys. And also we're going to develop satellite data infrastructures. So we believe that satellite data is very useful for marine affairs, not only for IU fishing detections, but also coastal management or tourism, aquaculture management, or even nowadays we are very interested about the marine debris or something. So we can use satellite those images and marine data sets, not only for IUU, but also we can open to other interesting topic on ocean. And this is the purpose of our satellite data analysis application. We're going to develop the application for defining highly potential IU fishing activities with soil image. So if we can do that, and the surveillance team can go to the target area faster than before, and also surveillance team can make a surveillance plan, arresting plan for the using our satellite data analysis results, and they can predict for the next stage or next area for the IU fishing. And this is the flow of data analysis. First, we're going to detect fishing vessels by satellite image, and we can compare with AIS or VMS data sets, and we can separate good guy and bad guy. And also we overlay with the potential fishing ground image, and also sea features with satellite image, and we can compare that area must be the potential area for IU fishing vessels. So we can try to do many times, and we're going to make statistical results, and then we can suggest to KKP staff which area is the potential area for IU fishing. Now, this is one of the image, something like, the fishing boats. It's like very small for detecting by satellite image. So it's like a square, white square only on the sea surface area. So black area is about the sea surface, and circle on the right image is about vessels. And also we can compare with signals from the vessels, and we can check which one is good, which one is bad. And also we can compare with other satellite images and other marine data sets. And then we can narrowing down the target area to narrowing down the target area because we understand Indonesian Ocean is too wide. It's very difficult to manage, very difficult to control, but we can detect in potential area, and they can have the surveillance more. We're going to suggest optimized surveillance plan with satellite image. And this is our activities. One of my colleagues is from Indonesian lady, and she also working our team right now. And she also had the capacity building with the KKP staff in Prancha. And this is the overview of the data platform. So now, as I told you that satellite data is not only for IU fishing detection, but also potential fishing ground, mangrove management, aquaculture management, tourism, and also marine debris monitoring system too. And last May and June, me and my colleagues visit to Jumbrana, and we installed the server systems. And now I'm here, and tomorrow I'm heading to Jumbrana again and start the open platform systems for KKP staff, and we cooperate together. And this is our activities image. And the last thing is about the sync observation. So now our purpose is using satellite data for detecting IU fishing this time. But satellite data has a large spatial resolutions. It's like about 50 meters resolutions, which means one square pixel is about 50 meter by 50 meter. But I think you've already known that Indonesian fishing vessel is very small, like 20 meters or less than 20 meters. So I think it's a bit difficult to detect the fishing vessels, but we have to do that. So now, at the time last June, my colleagues and I hire the fishing boat with a local fisherman, and we try to observe this with the satellite, and that's the observation. So this is our boat. So it's like 17.6 meters length. So it's very, of course, it was a very nice ship, but for the satellite detection, it's very small. Yes, and that's our result. So we have battery trouble when we're going to leave the port, but now we went to the north part of the West Valley between Java Island, and we wait for the satellite. And this is the satellite image with our locations. So our boat comes to the south to the north, and it's floated. So we're waiting for the satellite observation starting time, middle time, and end time. And with the human eyes, in the red circle is our actual locations, our actual boat. But using satellite power image, it's difficult to recognize where we are. But of course, we have the GPS, and we knew where we are, but with the satellite image, it's too difficult. But of course, we have some equation to detect fishing vessels. So now with the right image, you see the white square, that's our ship shadow, and we can detect very small vessels with large spatial resolution satellite image. So now we can say that satellite data has a good ability to find out the fishing vessels for Indonesian Ocean, and we can use and we can optimize the IU fishing vessel surveillance for Indonesian government and Indonesian territory. And terima kasih. And that's it about my presentation. And terima kasih. Terima kasih.
Thank you for Dr. Shinsaku Nakamura. Okay. Adik-adik sekalian, you can sit. Adik-adik sekalian, paparan tadi sangat luar biasa. Indonesia kita ini punya di radar satelit Indeso di Peranca. Tadi disampaikan oleh Dr. Nakamura, dan itu kita punya. Saat ini masih bisa mengcover seluruh Indonesia sampai ke barat Australia. Dan informasi tentang IUU fishing practices itu 80% itu disupport dari Peranca. Itu yang jadi bahan keputusan IUU fishing combating di Indonesia. So apalagi bagi taruna itu yang sulit untuk melakukan hal yang sama. Di sini saya kira Pak Suharyanto dan teman sekalian yang paling penting justru nanti bagaimana technical cooperation setelah ini. Itu Pak Direktur mohon izin. Well, ladies and gentlemen, now we are come to the opinions. Kalau ada opini-opini, pendapat-pendapat, mungkin and a question. Karena waktu yang sangat pendek, Pak Direktur, so there will be 2 or 3 sessions, and each session is for maximum 2 question. Ya, jadi kita akan bagi 3 sesi penanya. Setiap penanya paling banyak 2 pertanyaan kalau ada. Itu Pak Harya. Nanti kalau silakan dari para dosen atau taruna silakan akan menyampaikan. And please raise your hand, ya, or stand up atau berdiri. And don't forget to mention your name. Karena dosen mencatat ini, ya Pak Harya. Ya, don't forget to mention your name before giving opinion or question. Oke, silakan siapa yang akan bertanya dulu. Oke, langsung saja ya. Tolong dibantu. You can speak in English or Nihongo, right? In bahasa oke, ya. But better try your best. Yeah, in English.
Check. Okay, good morning, everybody. I'm Amanida Bakri. I'm from Fixing Technology. We know Indonesia is a rich country. Indonesia have 70% waters, and I think Indonesia can be developed country, but why not? And I want to ask a question, sir. Japan is developed country. What you think? I want to know what you think. What can we do to be better Indonesia than now? Thank you.
Langsung dijawab atau mau ada lagi satu lagi? Ada lagi? Mungkin jawab saja dulu ya.
Yes.
Well, thank you very much. What was your question? So where is the how to say the
No,
please.
my question is, what can we do? What can we do to be better
Okay.
Indonesian
Well-
fisheries? Excuse me, sir, because
Yeah.
and
I understand. Okay, thank you very much.
okay,
Well,
you're welcome.
thank you very much for your questions. What you can do, of course, study well, keep in school. Okay. This is very important, but also please, if you have any chance, please go outside of the Indonesia. For instance, for me, after I graduated the high school, I went to the United States and studied at the college and also school. And during my college period, I learned a lot of things, and I was surprised that we, of course, in the outside of Japan, I compare with the United States economy and power, or how to say, political things, even also the technology, to science and technology. Of course, I'm a scientist, also I learned a lot. But once we come back to Japan, and also now many, of course, we invite many Indonesian students at my office, and we invite internship or students, college students or school students here, and we learn about remote sensing in GIS. And I understand, please try to find out your interesting topic, and how, please consider about how you can solve these issues or topic, and then struggle hard. And I think once you overcome, or you can solve the problem or issues, and now your country is going to be better, and your skills also increase, and you better too. So it's like a step by step, but this time, please study hard here at the Polytechnic.
Okay, thank you, sir. Thank you very much.
I think it's very clear response, not only the question, but another also. Oh yeah, siapa? Okay. Cek. Cek.
Assalamualaikum, morning. Permission, Sir Nakamura. Permission, lecture. Permission, sister. Permission, French 50 Act. Permission, sorry. I not asked from PowerPoint presentation now, Sir Nakamura. If satellite observation not us not us try, what is satellite plan next and impact from what? Try.
Boleh pakai bahasa?
Jika satelit observation, pengamatan tidak berfungsi dengan baik, apa dampak pada dunia, dan apa rancangan ke depannya? Siap. Thank you.
The question is very big question, yeah.
The satellite operation is very important for the human activities, because now I'm focusing on Earth observation satellites now, and also people now, and also nowadays our how to say, our conference also now considered to be to the moon or deep space right now for developing the resources, and so satellite operation is very important to enhancing and improving our science technologies. And also this is one of, for the Earth observation satellite, this is one of the key technology, how we can make a balance for the human activities and development, and also environment maintenance. If we can use satellite image, and we can understand the phenomena on the Earth, and we can consider, we can check our activities, and we can check the environment and how much damage the environment can accept it, but how much we have to take care of the environment and try to save the Earth, and also try to achieve the SDGs, Sustainable Development Goals, together with not only Indonesian people, not only Japanese people, but also whole the world people, whole the world. Yes.
Thank you, Dr. Nakamura. Another question from this side, maybe? Okay. It's already 11:30, but still maybe one or two questions. Okay, please.
Assalamualaikum. Good morning. Excuse me, I want to introduce myself. My name is Muhammad Altaf Nur Bambang. I am from Processing Technology. Here I have a question about this material. But I want talking with bahasa. Baik, mohon izin. Pertanyaan saya mengenai materi pada pagi hari ini ialah yang pertama mengenai pemaparan materi pada pagi hari ini, yakni di mana satelit data analisis telah kita tahu bersama saat ini pemerintah terutama KKP telah sedang menjunjung tinggi mengenai blue economy. Nah, apa kesinambungan antara satelit data analisis terhadap visi pemerintah terutama KKP dalam mengusung blue economy. Terus juga pertanyaan selanjutnya yakni apa dampak program mengenai data analisis satelit ini terhadap aspek-aspek lingkungan, baik itu lingkungan perairan itu sendiri maupun lingkungan yang ada di sekitarnya. Sekian, terima kasih. Wassalamualaikum warahmatullahi wabarakatuh. Good morning.
Ya, terima kasih, Dek. Jadi, Derek.
Thank you very much. This is a very, very important questions. Yes, for the blue economy, of course, this is a very important for human activities and also for the maintain the environment. So satellite can observe very wide areas at one time and also continuously and also quantitatively. So which means that we can, so we can calculate how much the fish we can capture and how much we can save the resources in the under the water, and we can save. So now, of course, blue economy is very important, and I'm still learning about how we can apply satellite image to the ocean and blue economy and human activities. So please, if you have any good idea, suggestions, please share us. And I think this is one of the steps to consider about to develop together with develop together.
Oke, thank you. Anda paham ya, nangkep ya, bahwa blue economy itu adalah satu konsep keseimbangan dari ekonomi, kemudian sosial sama environment. Disampaikan bahwa riset ini, satelit ini bisa mendukung untuk melihat berbagai aspek yang berhubungan dengan resources sebagai resources untuk kepentingan pembangunan ekonomi di Indonesia, dan keseimbangan ekonomi, ekologi dan sosial itu menjadi hal yang penting, dan dukungan teknologi menjadi juga sangat penting untuk mewujudkan ini semua. I think that's all. So maybe one more question. Taruni, yeah, Taruni, you have question? The only one. So, and it is the last question, I think, because time running very, very fast. Yeah.
Yes. Good morning, sir. To Honorable Mr. Harry as the Director of the Ocean Institute of Indonesia and Mr. Maman. Thank you for the time that given to me. Let me introduce myself first. My name is Aina Ashifa Umi, and my major is fish processing. So my question is, a lot of sensor you mentioned before, In your opinion, which sensor that much more suitable for Indonesian fisheries, especially for reducing the IUU fishing? Thank you.
Yeah, thank you very much. This is very also important questions, but I cannot say which satellites, which sensors are very useful for Indonesian marine affairs, because data combination is the most important things. Not only one sensors, but also 2, 3, 4, 5. Many sensors we're going to use. So last time I showed you about the I showed you like Peruvian Amazon image, illegal mining areas. With the optical sensors, we just know about the area of illegal mining activities, but also with radar sensor, microwave sensors, we can detect for the next target point. So combinations are very important. So please, if you are very interested about satellite, try to use a lot of data sets. Okay, thank you very much.
Thank you very much. Great applause. So I think it's very clear answer, right? Yeah. Pak Direktur mohon izin karena waktunya sudah menunjukkan lebih 5 menit kita. So, well, ladies and gentlemen, finally we are come to the last agenda. We would like to say thanks again for the presenter, Dr. Nakamura. Very nice presentation and very good response. We appreciate, for your response and all of the audience for active participation today. The conclusion of the general lecturer today, maybe the committee will write down, and then we will distribute for the student and all of us. Pak Direktur, Bapak sekalian, hopefully the presentation will give benefit for us, for student, Polytechnic AUP, and thank you for your attention. Last but not least, these acknowledgements are dedicated to my beloved campus, Polytechnic Ahli Usaha Perikanan Jakarta. Applause. And I am as a moderator, I do apologize if there are shortcomings in leading this session. See you later. And again, give a big round of applause for Dr. Nakamura. Okay. Thank you very much. And the session I give to the committee. Please, Pak Ketut. Thank you very much.
Thank you, Pak Dr. Maman. And next agenda is, I think Pak Director would like to present Pak Director, we invite you to give a souvenir to Dr. Nakamura. For Dr. Nakamura, please receive. Camera. Over there. Thank you very much. And then this is the end of our general lecture. We do hope to see you again, Mr. Nakamura. Thank you very much and good morning.
Yang kayak ini kan? Satu lagi, Mas.